All right, so in this video we are going to discuss a topic called recursion in programming. So I have set up a Unit 3 project in BlueJ. If you forget how to do that, just open up any BlueJ project and then just go to Project, New Project, set the destination folder up here, and then give a name to your project or your folder name. Okay, so I've already done that, and I've created a new class called Intro to Recursion. All right, so recursion is going to be complicated at first. It was for me when I learned this, and it took several examples for it to really click. So just take that warning at the beginning. For those of you who have not studied recursion yet, this is going to be a bit of a challenge. We're going to start with some easy examples and then kind of work our way up to a much more complicated example, and that is a recursive sorting algorithm called the merge sort, which we will see is much faster than traditional iterative sorts like the bubble sort and selection sort. Okay, so I've created just a simple class here called Intro to Recursion. And we have a main method right here, and I have a little comment that just says recursion is simply the process of a method calling itself. All right, so I've built a little method down here as an example called message. This doesn't return anything, so it's a void procedure method, and it doesn't accept any input parameters. So what does this method do? Well, it's simply just going to print a little message. It just prints hi, and then I'm calling the method from within itself. So, as you might expect, this just calls this method again, and it's going to print hi, and then it's going to call itself again over and over and over again. So you might suspect what is going to happen here. Let's see how BlueJ handles this. So I'm just going to call a message, and because this is a void procedure, I can just say the name of the method because nothing's being returned, and then there are no parameters for me to pass down, so I still have to have the parentheses, but I don't put anything inside. Okay, so when I compile, no errors, good, and when I run it, okay, so we had a bunch of errors, and then it took me back to my code, and it says that I have a Stack Overflow. I just want to see if I still have that. Yeah, if I show the terminal window here, and if I scroll up to the beginning, you'll see, no, okay, I was going to say that it did work for a little bit. So it did print hi over and over and over again, and then we got to a Stack Overflow. So basically we had an infinite loop, and we ran out of a section of RAM in this case. And so this is where recursion can go wrong, and this will happen from time to time when you are making your own recursive methods. You may get some infinite recursion. So BlueJ just lets you know that that's going to happen. So we just kind of like with a loop, we do have to have a stopping point. We need to determine when to end this recursion, because right now we have an infinite recursive loop happening here. So let's say I wanted to print this message. Let's say I wanted to print it 5 times. So pretend I wanted to add a parameter in here that determines how many times I want to print hi. So of course I need to define that in my method header. So I need to declare a number, an integer. So n is going to represent this number, whatever I decide to put there. So all right, you all should be able to do the iterative case. So if you just set up a loop that runs from 1 to n, hopefully all of you have no problem doing this. And then we don't even need to do this recursively. You could just do this iteratively. So this should run, and this should print hi 5 times, no problem. Why is it printing twice? Interesting. Let me try that again. Okay, there we go. That was weird. So we are printing hi 5 times. So this should be no problem, but we didn't come here for this. We came here to learn about a recursive way to do this. So what we could do is we could say, we can have an if statement saying if n is equal to 1, then we are simply just going to print nothing. Okay, but actually, sorry, this my mistake. If n is equal to 1, we're going to print high. All right, but if n is not equal to 1, we are going to print high, and then we're going to call this method again, but this time we're going to pass in n minus 1 as the parameter. Okay, so basically every time you call this method, we are taking 1 off of this number, which started off being 5. So now we're saying message 4. So then we're going to call this method with a 4 as the parameter. So then we check our stopping case here, and this is false. So we're going to go to the else. So we're going to print high again, and then we're going to say message 3. So then we're going to call this message with a 3 as the parameter. This is still false, so we go to the else and we print high, and then we say message 2. So this is 2. Again, it's false. We go to the else. One more time, we're going to print high, and then this is going to be message 1. So the parameter is 1. So now this becomes true, and then we're going to print high, and notice we're not calling the method again. So this stops the method. This stops the recursion. Let's just check to see if this works here. Okay, yeah. So we get 5 highs. Again, I could change this. I could put let's just say I put 7. So if I compile, okay, so we get 7. And let's check this case if I put 1. Okay, so that works. One more tricky case. What if I put 0? So this might, yeah, this does something strange here. It gives us another error. So we get some infinite recursion again. So if I put 0 in here, this will never ever become true because I'm always calling message of n minus 1, and it'll just go on forever. So just a little trick here. For this if statement, it might be safer to put less than or equal to 1. So that way, if the main method puts any value in here that is less than or equal to 1, it's just going to print high once and then be done with it. Okay, so I'll change that back to 5. All right, so this is called a stopping case, or it's also called a base case. And this is very important in recursive programming. You're going to need to have, usually it's an if statement that determines when this recursion will end. All right, so this is called the base case. It's not always 1. It depends on what the program is that you're writing. And then this step down here is called the recursive step. So this is what just basically calls the method over and over again. And it's important not to forget to subtract 1 from n. You're not always subtracting 1. Sometimes you're subtracting a different number. Sometimes you're adding a different number. So it all depends on the task that you're doing. Okay, so here is a simple example of recursion. Now, you might be thinking, well, why would we be doing this? Why don't we just do it the easy iterative way with a for loop? So it turns out that this example here is not any more efficient. Like running this is not gonna run any faster than if you just used a for loop. I'm just really setting up this example as a demonstration of recursion and what it looks like. So there are many cases where recursion doesn't win you any battles. The for loop iterative version would be just as fast. It's when you get into larger tasks like sorting an array of 1,000,000 values, then a recursive algorithm will save you a lot of time, and we're going to see that if not today, then in the next lesson. All right, so one more example is, what if we wanted to do, I'm just for illustrative purposes, I'm going to get rid of this just so it's not in our way. And I'm going to create a new function called Factorial. And this is going to be a function, so it's going to return an int, and it's called factorial. Some of you may have heard of this before. We may actually have even done it in comp sci. But you may have heard this from math class, especially if you're taking data management or advanced functions. That factorial may have come up in the course. But in math class, if I say something like 5 factorial, and you may see it as the exclamation mark. Don't confuse this with Java, where that's called the not operator. In math class, this is called the factorial operator. And what it means, 5 factorial means 5 times 4 times 3 times 2 times 1. And so the answer to this is 120. So 5 factorial is equal to 120. So what if I wanted to write a method called factorial that takes in a number, an integer, and it returns the factorial of that number? All right, well, hopefully you could do that quite easily with a for loop. You could make like a total variable and set that equal to 1. And then you could just say for int I equals n. And then as long as I is greater or equal to 1, I minus minus. And then in that loop, you could say total times equals I, and then just return your total. Let's just see if that worked. So up here, I'm going to say factorial of 5, but this won't work because it's a function. I'm getting a value back. So this is like a dead statement right now. I need to print this to see if it worked. Okay, so let's see if this prints 120. Okay, it's still printing my last value, which is weird because I have clear screen at method call. Let's try running that again. Okay. I wonder if that had something to do with my Stack Overflow that I had before. Interesting. Okay, so now how would I do this method recursively? So this is the simple iterative way of doing it, but how could we think about programming this differently using recursion? Well, the factorial is a nice example for this because 5 factorial can be written like this. So a factorial can be written as a product of another factorial. So in other words, you're calling the factorial method from within itself. Okay, so if this doesn't make sense up here, look up here. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. So that highlighted region, that is actually just 4 factorial. So this would be true. And as a general case, n factorial is equal to n times n minus 1 factorial. Okay. So this will be useful when coming up with a recursive factorial method. I hope you're still with me. I hope I haven't lost you. If you've faded out, go and rewind and watch again. Really focus. I told you this stuff can be tricky, but with practice and with focus, you can get this. All right. So here is my factorial method. I'm going to try and code this recursively. So let's get rid of all this. So we need a base case. We need a stopping case. Well, if n is 1, what would be the answer? Well, 1 factorial is just 1, right? So if this is the case here, if n is equal to 1, I'm just going to return 1. But remember the last example, I said it might be safe to do less than or equal to 1, and that would be the case here too. So for those of you that have studied the factorial, you'll know that 0 factorial is strange. You might think it's equal to 0, but it's not. It's actually equal to 1. Now, there is a mathematical proof of this, why 0 factorial is equal to 1. We won't get into it here, but I'd invite you to go and research that if you'd like. But 0 factorial is equal to 1 as well. So this is actually convenient for us because we can say if n is less than or equal to 1, then we're going to return 1 and we're done. We're done with the method. All right. So the harder part is saying, well, what if it's greater than 1? So what if this parameter is like 5? Well, we're going to return n, so Basically what I'm going to do right now is code this. I'm going to code this statement right here. So I'm going to do n times the factorial of n minus 1. And that's exactly what we type here. This is the recursive step. It's going to equal n times factorial n minus 1. And so this is going to call the method again, but this time it's going to pass a 4 in as a parameter. So that is it. That's the recursive program. Notice there's no loop here. There is like a recursive repetition happening here, but within the code there's no for loop, there's no while loop. It's just an if statement. Okay, so if you're still just a little bit foggy with this, I'm just going to open up a Word document, and let me just move it over a bit here. Okay. And let me see. Actually, you know what? I'm just going to I'm going to copy this and paste it here. And let's change that font to a fixed. Make this font a little bit bigger as well. Okay, so I'm just going to show you an example, just in case you're not quite sure how this is working. So let's change the color, and let's assume I call, so in the main method I say factorial of 5. Actually, let's make it a smaller example just to speed things up here. So if I say the factorial of 4, okay, so 4 gets passed into this method. And then this is going to be false. This base case is going to be false. So then I'm going to go to the else, and I'm going to return 4 times the factorial of 3. I'm just going to move this out of the way. Oh, I'm going to write it up here. Okay, so this was the original call, factorial of 4. I'm trying to figure out, I'm trying to call this method just to see how this is working. Okay, so 4 gets passed in as a parameter. The base case is false, so that means I'm going to return 4 times the factorial of 3. Now, we're going to call this method again. We're going to call factorial of 3. So just pretend we're calling this method from the beginning. So that means the parameter now is going to be a 3. And so the base case is still false. So this factorial of 3 is going to be returning 3 times the factorial of 2. Okay, because that's what this return statement says, n times factorial of n minus 1. So now I want to figure out, well, what does this give me? What does factorial of 2 give me? So I'm going to call this method all over again, but this time the parameter is a 2. The base case is still false, so I'm going to go to the else, and I'm going to return 2 times the factorial of 1. And so I call this method factorial of 1. So the parameter is going to be 1. And now my base case is true. So now I'm just going to simply return 1. So this gives me back 1. Now, where does it return this to? Where does this 1 get returned to? Well, it gets returned back up to this level here, and it gets multiplied by 2. And that gets returned back up to this factorial 2 and multiplied by 3. So that's going to be 6. So 6 is returned up to this factorial call, which is then multiplied by 4, which is 24, and then that gets returned back to the main method or wherever you called factorial 4 to begin with. Okay, so I hope this makes sense. If it's still a little bit cloudy, reach out to me, send an email, ask, and we can do another example. But hopefully this made sense. So we'll work on some examples in class, and I'm sure you will understand recursion after we do a few examples. Okay, thanks for watching.